The lines L1 and the line L2 intersect at B. We have to find that. Let's do this very quickly. The first thing that we have to do is write in the IJK format. So let's still maintain the column vector format. So 3 plus lambda 1. Then we have 1 plus minus lambda. That means 1 minus lambda. And then we have 2 plus 4 lambda. So this would be 2 plus 4 lambda. This is L1. And L2 would be R equals to 0 plus 1 mu. That means 0 plus mu. Then we have 4 minus mu. 4 minus mu. Then we have minus 2 plus 0 mu. That means minus 2 plus 0. That's all. So we have this. Now what we have to do is, if they're intersecting, the two vectors should be equal. That means comparing I, comparing j, comparing k, or simply we can just write these two column vectors equal. 3 plus lambda 1 minus lambda 2 plus 4 lambda equals to mu 4 minus mu and minus 2. So we have three equations here. So if I take the final one, 2 plus 4 lambda equals to minus 2, I can easily find the value of lambda. So lambda would be minus 4 divided by 4, which is minus 1. Now, since we know the two lines intersect, there is no need to find the value of mu. We can simply put the value of lambda and find the point of intersection. So for lambda equals to minus 1, I'm putting it here in L1 because it has lambda. So we can write the position vector OB would be equals to 3 minus 1, that means 2, 1 minus minus 1, that is 2, 2 plus 4 into minus 1, that means minus 2. So we can write it in the IJK format, 2i plus 2j minus 2k, and the coordinates would be, therefore B has coordinates 2, 2 minus 2. In question number B, we have to find the angle between the two lines L1 and L2, and that's the dot product. First of all, so cos theta equals to direction vector of L1 dot direction vector of L2 divided by modulus of the direction vector and modulus of the second direction vector. So that turns out to be, so 1 minus 1 4, that is the direction vector of L1, 1 minus 1 4 dot, I'm writing this as the column vector format. So direction vector is here with mu 1 minus 1 0, so 1 minus 1 0, and the modulus of this is 1 square plus minus 1 square plus 4 squared. Then square root of the second direction vector modulus is going to be square root of 1 square plus minus 1 square plus 0 squared. So now we can do the dot product, that is multiplying the coefficient of I with coefficient of I, coefficient of j with coefficient of j, and so on. So 1 into 1 is 1, plus minus 1 into minus 1 is 1, plus 4 into 0 is 0. And this is going to be square root of 1 square is 1, plus minus 1 square is also 1, plus 14 square is 16. So 16 plus 2 is 18. Square root of, this is going to be 1 square is 1, 1 plus 1 square is 2. So this is 2. So 1 plus 1 is 2 divided by square root of 18 into 2 is 36. This is going to be 2 by 6, which is 1 by 3. All we have to do is find the value of cos theta. Cos theta is 1 by 3. So the point A lies on L1. So if this is L1, this is L2. What we know, L1 and L2 intersect at the point B that has coordinates 2, 2, minus 2. We also know L1 and L2 makes an angle so that cos theta is 1 by 3. So this is the angle that we found, theta. Now we know that a point A lies on L1. So this is A, and it has position vector 3i plus j plus k. That means 3, 1, 2. And we have another one over here that has point C, and it lies on L2. And it has position vector 5i minus j minus 2k. So 5 minus 1 minus 2. So this is the information that we have. So we have to show that the modulus of the vector AB and the modulus of the vector BC, they are equal. So let's do this over here. Question number C. So AB vector equals to OB minus OA. Let me write down the column vector, it's quicker. So OB is 2, 2 minus 2 minus OA. So OA is 3, 1, 2, and ultimately this is going to be 2 minus 3 is minus 1, 2 minus 1 is 1, minus 2 minus 2 is minus 4, and the modulus of this is going to be square root of minus 1 squared plus 1 squared plus minus 4 squared. So this would turn out to be 1 plus 1 plus 16, square root of 18. And after that we have to find BC. So let's find, let me do it over here, BC. So BC is going to be OC minus OB. So OC is given, it is 5 minus 1 minus 2, and OB we already found, 2, 2 minus 2, and this turns out to be 5 minus 2 is 3, minus 1 minus 2 is minus 3, minus 2 minus minus 2 is 0. So modulus of BC would be square root of 3 squared plus minus 3 squared plus 0 squared. This would be 9 plus 9, 18. Therefore, AB modulus equals to BC modulus. Both are square root of 18. Question number D says, find the position vector of D. But what is D? The point D lies on ABC plane such that ABCD is a parallelogram. That means, so the D must be over here, somewhere over here, so that this turns out to be a parallelogram ABCD, so that ABCD is a parallelogram. Now in order to find that, we have to use the rule of the diagonals. That means the diagonal of this and the diagonal of these 2 points, they have the same midpoint. So we don't know what that midpoint is, but we can separately find the midpoint. So we can find the midpoint of AC and the midpoint of BD. Since they have the same midpoint, we can find the coordinates of D. So suppose the coordinates of D is X, Y, Z. So we can do this by, so question number D. So first of all, midpoint of AC. This is the midpoint of the vector AC. So let's find the coordinates. So it would be x1 plus x2, which is 3 plus 5 by 2, y1 plus y2, which is 1 minus 1. So this is going to be 1 minus 1 by 2, and 2 minus 2, which is going to be 2 minus 2 by 2. So the midpoint turns out to be 8 by 2 is 4, 0, 0. Now let's find the midpoint of BD. So the midpoint of BD, that is going to be, we don't know what D is, so this is X. So X plus 2 by 2, then Y plus 2 by 2, and Z plus minus 2 means Z minus 2 by 2. So we found both the midpoints, and we know for parallelogram the midpoints are the same. The diagonals meet at the same point, they bisect each other. So we can write the X equals to X. X plus 2 by 2 equals to 4. Therefore, X equals to 4 to the 8, minus 2 is 6, and Y plus 2 by 2 equals to 0. Therefore, Y equals to 2 into 0 is 0. So that becomes minus 2, and Z minus 2 by 2 equals to 0. Therefore, Z equals to 2 into 0 is 0. So minus 2 plus, this is going to be 2. So D has the coordinates of 6, minus 2, and 2. It's a good idea to always check with the answer format. So find the position vector. So we don't have to find the coordinates of D. We have to write down the position vector. Therefore, OD equals to 6i minus 2j plus 2k. So what we have over here is 2 points. The position vector of 2 points are given, and the line AB has vector equation. So basically this line AB is the line L. They usually call it L. Now they're calling it the vector equation of the line that passes through AB. So this is what's happening. So we have a line that passes through AB, and they're calling this the vector equation of the line. Let me call this L. So first of all, we have to find a constant. Remember, for finding a particular point, if a point lies on a line, the value of lambda for that particular point is same for every coordinate. Okay, so let's write this in the ijk format. So 5j, so I is 0, so this is going to be 0 plus 2 lambda I plus, so 5j plus lambda j, 5 plus lambda j plus 11k plus 5 lambda k, 11 plus 5 lambda k. So this is the universal position vector format for L1 or line L. So we have OB. So OB has CI plus DJ plus 21k. We don't need OA over here because we know all the coordinates of OA, 5j plus 11k. But we are asked to find the value of C and D. So for that we are using this. So what we can do here is we can find the value of C by comparing the coefficients. So for I equal to I, C is unknown, J equals to J, D is unknown, and K equals to K, we can find the value of lambda. So for K equals to K, we can write 11 plus 5 lambda equals to 21. Therefore, 5 lambda equals to 10. Therefore, lambda equals to 2. Since we know that lambda is the same for each coordinate, if lambda equals to 2, we can write for I equals to I, it would be 0 plus 2 lambda, meaning 2 into 2, 4, equals to C. Therefore, C equals to 4. Then for J equals to J, we can say the coefficient of J is 5 plus lambda. That means 5 plus 2 equals to D. Therefore, D equals to 7. So we know the value of C and D. It is 4 and 7. Now the same question can be done in another way, in the column vector way. Let me show it in this way. So this is the alternate method. So what we do is we write down the universal position vector, meaning line L, in the column vector format, and it turns out to be 0 plus 2 lambda is 2 lambda, 5 plus lambda, and 11 plus 5 lambda. And we also write the position vector of B in the column vector, and this turns out to be C, D, and 21. And we solve the equation like this. If they're intersecting, we can write 2 lambda, 5 plus lambda, 11 plus 5 lambda equals to C, D, 21. And then we can solve it. So, 11 plus 5 lambda equals to 21. Therefore, lambda equals to 2. And so 2 lambda equals to C. Therefore, C equals to 2 lambda, meaning 4. And D equals to 5 plus lambda, meaning 5 plus 2 equals to 7. So we can also do the same question in the column vector format. Next, we have the same question, the point P. It's a pretty common question. So we have a point P that lies on the line passing through AB. Let me call that line L. So we have that point, and so we have to do this. So this is the line L, and this is the point P, and it is perpendicular to the line L. So it lies on that line, and it is also perpendicular. The position vector of that point is perpendicular. So the dot product of the line L and the direction vector itself, so they should be dot product is 0. So when we want to find the rule for perpendicular, if two lines are perpendicular, their dot product should be equal to 0. So first of all, what is OP? OP is the same as the universal position vector, because remember the definition of this line is for any position vector lying on this line, it's given by this thing. So we can write OP equals to 2 lambda, 5 plus lambda, 11 plus 5 lambda. This is OP. And remember the direction vector of this line L, so it's given over here. This is the direction vector right after the scalar quantity. So 2i is 2, j is 1, and 5. So this is the column vector format of the direction vector of the line L. So for the rule for perpendicular is that the dot product is 0. So 2 lambda plus 5 lambda, 11 plus 5 lambda dot 215 equals to 0. So dot product means multiplying the coefficient of I with coefficient of I. So 2 lambda into 2 is 4 lambda. 5 plus lambda into 1 is 5 plus lambda, plus 11 plus 5 lambda into 5 is 55 plus 25 lambda equals to 0. So this is 4 lambda plus lambda is 5 lambda, 5 lambda plus 25 lambda is 30 lambda, and we have 5 plus 55 is 60 equals to 0. Therefore lambda equals to minus 60 divided by 30 is minus 2. So we have to find the position vector. So OP equals to 2 lambda, lambda is minus 2, that means minus 4. 5 plus lambda, 5 minus 2 is 3. 11 plus 5 into minus 2 is 11 minus 10 is 1. So we can either write it in this way or you can write it in the IJK format. Minus 4I plus 3J plus K. In the final question, we have to find the area of a triangle OAB. So this is how it is working. We have this line A and we have B, and somewhere around here suppose we have P. So we know OP is perpendicular. OP is perpendicular. That was just the previous sum. So in order to find the area of OAB, we can write area equals to length of AB, which is the base, multiplied by the height. Half into base into height. So half into base. Base is the length of AB and height is the perpendicular OP. So the first thing we have to do is find the length of AB, and then we have to find the length of OP. So OP is going to be simpler. So OP, it's modulus of vector. So that is going to be minus 4 squared plus 3 squared plus 1 squared. And this is going to be 16 plus 9 plus 1, which is square root of 26. Now we have to find the length of AB. First of all, AB equals to OB minus OA. So we know what OB is. So OB is going to be 4, 7, 21 because C is 4, D is 7, and 21 is the coordinate of K. So now OA is also given. So it should be over here. So position vector of A is, so I is 0, 5, 11. So this is 0, 5, 11. So AB turns out to be 4 minus 0 is 4, 7 minus 5 is 2, 21 minus 11 is 10. So the modulus of AB, that is the length of AB, is square root of 4 squared plus 2 squared plus 10 squared. So 4 squared is 16, 16 plus 4 is 20, 10 squared is 100, 120. So area is going to be, so area of triangle OAB, half into base, which is square root of 120, into height, which is square root of 26. So let's see what the value turns out to be. So half into square root of 120 into square root of 26. It is 27.9.